Okay, who's this guy? So here's Australian chemist Carl Al Weschbach, specialized in studying the rare earths using spectroscopy, fine details given off when heated in the flame. In addition to inventing the gas mantle, he also invented the first metal filament electric bulb. So we're sort of, moving away from just, simple combustion into more electricity. And, this guy's living 1858. So he's born basically as the periodic table is being completed. As Mendeleev is completing, this guy's sort of, born into the world. All right, so here's your gas mantle. And again, this is just pyrolyzed coal. The volatiles are coming off, and there's still enough carbon gas, methane gas, and maybe some sulfur gas. And there you go, keeping the streets of London safe at night from criminals. There we go. Yeah. Okay. So we talked a little bit about coke. Coke is very high concentration carbon, going to burn much hotter. And, if you're going to start melting iron, you need a hot fire. So there you go. All right. And again, I apologize for ripping through this chapter so quickly, but it's, you're right. Okay. This picture of a, coal miner, not the most pleasant looking situation. This is happening right now in the Ukraine. There are people doing, backyard bathtub coal mining. They'll rip the bathtub out of the bathroom, dig the hole in the ground, and put it on a sled, and down you go. So kind of, back to this sort of, dark ages, if you will, of mining. More modern equipment, obviously. Here's a miner down with his face mask on, so he's not breathing this dust. Here is a conveyor belt. These things can be miles long. A buddy of mine I'm working with, his father was working the coal mines of Illinois back in the 40s and 50s. He was the foreman, last guy out, decided for whatever reason to dust off a little coal dust from the belt, got his arm caught, or sleeve or whatever, in the belt, dragged him about a half mile back into the mine, chewed through the majority of his arm. They found him the next morning, sewed it back on. So he was one of the very first successful arm grafts in the U.S. Is back in the 40s. So, yeah, ended his boxing career, though. This is all true, very true. I've got the book in my office. Craig Thomas, some pretty impressive stories from the coal industry. And here we go. One of the largest machines, invented by humans, being transported from one mine to another. Now this wheel is removing the overburden. So what we just saw in the previous shots were underground mining. This, in a lot of ways, is safer because you don't have the collapse and the fancy equipment and all that. So this this piece of equipment is just moving from one mine to another. There are some. I got to tour last fall coal strip, and it is amazing the size of these machines. So just a machine like that, it's a $30 million to $50 million investment. So you can see if you were the venture capitalist paying the engineers to build their $50 million machine, you better get $50 million worth of electricity back out of it. So that's why there's a lot of money tied up in the politics of keeping the fossil fuel industry alive. That paid a lot of welders' jobs right there. Pay a lot of engineers' jobs to make that. I mean, that's just impressive.
Getting that thing in place.
Yeah.
If you
Yeah.
go to the coal strip website,
Yeah.
the town coal strip,
Yeah.
on the front page they have a letter written by the mayor,
Oh, yeah.
whoever, and that's what it's about.
Yeah.
Is keeping the fossil
Keeping the
fuel
jobs,
going
yep.
there, 'cause it's so essential to their community, basically.
It's a big deal. And then you'll read the summary 2 paper and what about the atmosphere? What about
About
greenhouse gas?
long-term thinking.
Yeah. So yeah, no, we're a pretty special place in history. We really are. Really are. Okay, so here's a map of the reserves. I'm a little surprised. I mean, I heard recently that Montana has a third to a quarter of North America's coal reserves. You wouldn't guess that looking at this little map, but these are just, again, seams that were, buried hundreds of millions of years ago, and tectonic activity, buried them to some extent. But again, the harder coal, that stuff that's been around longer, and then the lignite that's, really old compost, really old peat buried underground and cooked.
And this is just the stuff that they know of.
This is the stuff we know of, which kind of brings us to the next figure. So a geologist will sort of understand how the earth is folded and caved and shifted and moved. So this is sort of what we know is there. This is what's sort of easy to get. This is just too deep. You can't build another $100 million machine to go and dig deeper. By the time you're done spending all the energy to get rid of the rock, whatever coal's down there is no longer profitable. And this is what might still be out there. So if it's hypothetical, you go and explore, boom, there it is, and it becomes part of the economy. You go explore, it's out there, sorry, too deep, not economical. If you watched the last Superman movie, 2014, 2013, so Superman, and this is just the Superman version, Superman's civilization mined out the entire core of its planet. And so now they're living on this sort of like little crusty sphere, and ultimately it collapses. So Superman is ejected off into space just as the entire planet is collapsing. So they mined all the coal, mined all the whatever, and they're just kind of living on this little eggshell of a planet, and it just, poof, at the end. So anyway, it's down there. Just keep on digging. And then, of course, Superman's father's like, no, we need solar power, we need renewable power. And so the struggle continues at the interplanetary level.
Well, Krypton was a largely Republican planet.
Yeah, it was ours.
Yeah. So,
Because they didn't just go and take over other planets.
well, that's exactly what happened. And if you watch the Superman movie, that's exactly what's happening. They were going and terraforming on other planets. Okay, so World Coal 2009. So you can see from this, from Table 5.1, the U.S. Has 28.9 or 28.9% of the world's coal reserves. So one argument might be, well, gosh, let's dig it up, let's sell it, let's capitalize on it. The other argument, like, well, it's so great, let's save it, let's literally bank it, keep it in the bank.
That's what they did with our oil reserves too.
Yeah. So there's that graph. There's another neat little thing here on boiling a liter of water. And let's see here. I'm just going to leave that as an exercise for you. But do take a look at 5.6. I'll spare you the math today, but I will want you to do this because there will be likely numerical problems like this on the exam. So do box. And for now, just follow along with it, 5.6. And basically what you're looking at is the volume or the mass of a piece of wood. And what you're trying to do is take a liter of water and take it from, I don't know what they say, from 20 C up to 100 degrees C. Boiling point, yeah. So it's just energy, going from chemical energy, again, we know what that is, we studied that already. You're going from chemical energy into thermal energy. All right. And finally, I know we're kind of running short on time here, but there are numerous styles of coal-fired power plants. Sort of going from the grate boiler, which is, fairly simple. The solids are coming in, they've been crushed. As they're heated, your volatile matter goes up, flue gases, in comes the water, out goes the steam. Steam goes through a turbine, spins a magnet, and out comes the electricity. Pulverized coal, it's just going to burn hotter and faster. Just think of a flash fire or a dust fire. This actually happened up at Algae Aquaculture. They're creating this purified carbon. They didn't have a proper carbon handling system, and boom. I mean, fire can be good, can be bad.
That's when they kind of make into a slurry.
They're making biochar mainly.
Investigation.
Yeah, yep. Here's another one, fluidized bed. So the coal's coming in, the air, and then the two separate sets of boilers. So what we're looking at there is something like here in Japan, where they'll have both a gas turbine. So think like jet engine gas turbine, where volatile gases are actually going through the engine. That's exactly what's happening in a jet engine, versus just a steam turbine, where it's just water's going through it to spin it. And we'll look in the next chapter. We'll see exactly what's going on with turbines. Here's just one more example. So this is a scrubber. Flue gases are coming in. Limestone slurry, and just in the last few remaining minutes, I am going to show you the chemistry behind this. This is sort of kind of wild. So here's the complexity that we've gotten to keeping SOx and NOx out of the atmosphere. So if you put in calcium carbonate, Ca, so there's Ca, CO2, plus, and the SOx, so remember we talked about what SOx are. SO2 is just one example of a SOx. Calcium sulfite comes out. So you still have your calcium coming along for the ride. Here's your sulfur, and here's your oxygen. This is actually a commodity. This is going into your gypsum. It's something. It's a building material, plus your CO2. So that's your SOx scrubber. The other scrubber, your NOx scrubber, looks like this. So 4 NH3, that's just good old ammonia, plus 6 NO. Nitrogen oxide is an extraordinarily powerful greenhouse gas. It's got a spectrum that absorbs a lot of the radiation that comes back off the earth. That just converts into nitrogen plus water. So this scrubber that I just showed you is one example of how you would bring in other materials to clean the gases. And what are the clean gases? Well, CO2 is a clean gas, if you will, a lot cleaner than acid rain. There's your acid rain. You asked about that earlier, Kat. Like there's your acid rain, and here's your very powerful greenhouse gas. But instead, you just got good old nitrogen and good old water coming off. Wow, I made it all the way through the chapter.
Nice work.
Thank you.
Through the whole chapter?
That was it.
Chapter,
That was chapter 5.
oh, chapter 5.
That was chapter 5.
Oh, yeah.
Yeah, so read the summary 2 paper, put a post up, respond to your classmates' posts, at least 2 by Tuesday. Get me your summary 2 by Tuesday, and then I'll see you next week for my second favorite chapter of the book.
Chapter 6.
Ooh.
Yeah, all right, see ya. Yep, thank you.
All even numbers, right?
I guess so, yeah, I like the even numbers.